Welcome students to our online lecture. Today we are discussing the important topic on highway geometric design. In today's video, we'll discuss side distance, types of side distance, stopping side distance, analysis of SSD, overtaking side distance, analysis of OSD, and overtaking joints. First of all, we'll come to know what actually the side distance importance in a geometry of the road. One of the important factors on which safe and efficient operation of a vehicle on roads depends is the road availability when an obstruction, if any, becomes visible to the driver in the direction of a travel. In other words, the distance visible ahead to the driver is very important for the safe vehicle operation on a highway. In simple words, we can say it is the length of the road visible ahead to the driver at any instance. Types of the side distances: stopping or absolute minimum side distance, safe overtaking or passing side distance, safe side distance for entering into uncontrolled intersection, intermediate side distance, headlight side distance. The, the following requirements should be taken into account during the design of road geometrics. The first one is what? The safe stopping. Driver traveling at the design speed has a sufficient side distance or length of a road visible ahead to stop the vehicle without collision in case of any obstruction on the road ahead. As the stopping is most essential requirement in to avoid collision, this requirement should be fulfilled all along the road section. Similarly, what actually the safe overtaking? Driver traveling at the design speed should be able to safely overtake the slower vehicles without collision obstructing or hazard to traffic of opposite direction at reasonable intervals. Safety at an uncontrolled intersection. Driver entering at an uncontrolled intersection has a sufficient visibility to enable him to take control of his vehicle and to avoid collision with any other vehicle. These are the very three important things which you should keep in mind whenever we design of a highways or for a highways or for a traffic control. Apart from these three situations mentioned above, the following side distance which are considered by IRC in a highway design are ISD and HSD. Then what is actually ISD? ISD is 2 times the SSD. ISD is provided when it is not possible to provide OSD. Similarly, HSD is what? Distance visible to driver during night, and it is mainly critical at vertical curves. SSD is the minimum side distance available on a highway at any spot having sufficient length to enable the driver to stop a vehicle traveling at a design speed safely without collision with any other obstruction. Then, for measuring SSD, IRC has suggested height of the driver's eye above the road surface should be 1.2 meters. Height of the object above the road surface should be 0.15 meters. Then SSD depends upon the following factors: total reaction time of driver, speed of a vehicle, efficiency of brakes, frictional resistance between road and tire. Now we'll go in detail each these parameters, how these will be affecting SSD. First, the total reaction time of the driver. It is the time taken from the instant the object is visible to the driver to the instant the brake is effectively applied. The total reaction time can be studied under two main parts. One is perception time, one more is what? Brake reaction time. Perception time is the time required from the instant the object comes on the line of the sight of the driver to the instant he realizes that the vehicle needs to be stopped. Then similarly, brake reaction time. The brake reaction time also depends on several factors such as the skill of the driver, type of the problems, and various other environmental factors. The total reaction time of the driver can be calculated by PIV theory. This PIV theory is nothing but P is what? Perception, I is intellection, E is emotion, V is violation. Then we'll go in detail what this actually the PIV theory. That is perception time. It is the time required for the senses received by the eyes or ears of the driver. Then intellection time is the time required for the driver to understand the situation. Emotion time is the time elapsed during emotional sensation and other mental disturbances such as fear, anger, or superstitious feeling. Violation time is the time taken by the driver for the final action. As per the standards, the total reaction time of a driver may vary from simple situation to complex situation from zero point 0.5 seconds to 4 seconds. Then speed of vehicle also increases along with the stopping distance increases. Efficiency of the brakes is said to be 100% if the wheels are fully locked, resulting in skidding which is undesirable. So avoid skidding, braking force shall not exceed the frictional force between road and tire. The last one is frictional resistance between road and tires, which depends upon coefficient of friction, that is F, between road and tire. IRC has suggested values of F in between 0.35 to zero point 0.4 depending upon the design speed. As the value of F decreases, the braking distance increases. Now next is analysis of stopping side distance. The stopping side distance is the sum of lagging distance and braking distance. The distance travelled by the vehicle at uniform speed during the total reaction time is termed as lag distance. The distance travelled by the vehicle after the application of the brakes until the vehicle comes to a dead stop position, which is known as braking distance. Then by the definition lag distance, I can write it as, that is, lag distance equal to V into T, where V is in meter per second, where T is the reaction time of the driver, which is taken as per the standard as per IRC 2.5 seconds. When I measure V in kmph, the formula will tends to be like this, that is 0.278 Vt. Yes. Then braking distance is obtained by equating the work done in stopping the vehicle and the kinetic energy of the vehicle moving at a design speed. If I assume the road is a level, then how I am going to calculate the braking distance? Work done against frictional force in stopping the vehicle is F into L, that is nothing but small f, W and L, where F is the coefficient of friction, W is the total weight of the vehicle, L is the brake distance. Then kinetic energy of the vehicle of weight W moving at the design speed is V meter per second is said to be W V square by 2G. If I equate these two, then I will be getting what the braking distance L equal to V square by 2GF. Therefore, SSD equal to lag distance plus braking distance. That is, I will write in the formula mathematically, that is SSD equal to Vt plus V square by 2GF, where V is measured in meter per second. Then SSD equal to 0.278 Vt plus V square by 254 F, where V is measured in kmph. Yes, then G is acceleration due to gravity. Similarly, if I am going to measure SSD at slope conditions, then what the formula tends to be, SSD equal to Vt plus V square by 2G bracket F plus or minus 0.01 into N. Yes, here N is what the slope, either it is ascending or the descending. Based on that, you will be using plus or minus. It is similarly, if the V is measured in kmph, SSD equal to 0.278 Vt plus V square by 254 bracket F plus or minus 0.01 N. Then the remarks for SSD, how you can make further remarks. Two-way traffic signal, a single lane road will be what? SSD will be 2 times the SSD. If it is a one-way traffic with a single or more lane, or two-way traffic with more than single lane, then minimum SSD will be what? The SSD only. Then these are the recommended longitudinal friction coefficient values for providing SSD. You can see from this table, if I go on increasing the speed, then I can see that there is a decrease in the coefficient of the friction value. That is what which has been suggested by the IRC, and a simple pictorial representation where you can understand the stopping distance. Now we'll come to one more type of the side distance, that is what? Overtaking side distance. See, overtaking side distance is very important. If all the vehicles travel along a road at the design speed, then theoretically there should be no need of for any overtaking. In fact, all the vehicles don't move at the design speed, as each vehicle driver is free to travel at lower speed, and this is particularly true under mixed traffic conditions. In such circumstances, it is necessary for fast moving vehicles to overtake or pass the slow moving vehicles. Therefore, efforts should be made to provide adequate side distance along the road alignment to enable vehicles traveling at a design speed to safely overtake slow moving vehicles. Now, what is actually overtaking side distance? The minimum distance open to the vision of the driver of a vehicle intended to overtake slow vehicle ahead with safety against the traffic of opposite direction is termed to be as minimum overtaking side distance or the safe passing side distance. And what are the IRC suggested values? Criteria. Overtaking side distance or OSD is the distance measured along the center of the road which a driver with his eye level with the eye level to be 1.2 meter above the road surface can see the top of an object of 1.2 meter above the road surface. These are the IRC suggested values for OSD. Then what are the factors affecting for OSD? Speeds of overtaking vehicle, speeds of overtaken vehicle, speeds of the vehicle coming from opposite direction if any, then distance between the overtaking and overtaken vehicles, skill and the reaction time of the driver, rate of acceleration of overtaking vehicle, gradient of the road. These are the simply what you can understand the factors affecting OSD. Then how to analyze this overtaking side distance? Here I have shown very simple two-way movement of a single lane road where you can see here the different colors of the car. The first one is what blue color and next one is what yellow color which is moving in the same direction, and cream color car is moving in the what in the opposite direction. Now OSD is what? It is a summation of the three distances as shown in the figure, that is D1, D2 and D3. Now we are going to calculate what would be this distance D1 and what would be this distance D2 and what would be the distance D3. Yes, now I will just go on detailing what actually these cars having the speed. Yellow car is traveling at a speed of VB meter per second. When I say VB meter per second, it is tend to be a slow moving vehicle car. Then blue car and cream car are traveling at a higher speed of V meter per second. Now first I will calculate what is the distance D1. Then from the figure I can say the distance D1 is the traveled by the blue car. I can write by the definition of speed, very simple, that is VB into T. Blue car must reduce its speed and travel beyond yellow car at a some speed as that of yellow car, waiting for an opportunity to overtake. This distance covered in reaction time of t seconds at a speed of VB meter per second is what? The D1. Yes, that is what the clarification of D1. Similarly, we go with the what? D2. Distance traveled by blue car. It is B plus 2S from the figure. Yes. Then what is that B? B is what? The distance traveled by the yellow car. The distance traveled by the yellow car, the slow moving vehicle. Where T is the overtaking time in seconds. That value of T depends on the speed of overtaken vehicle yellow car and the average acceleration A meter per second square of overtaking vehicle blue car. Then if you simplify with the fundamental laws of motion S equal to ut plus half at square, you will come to know what? The T value, the overtaking time operation, that is square root of 4S by A, and S is the minimum spacing between vehicles which depends upon their speed, and it is an empirical formula S equal to 0.7 VB plus 6. Then if you substitute all these, you will come to know what the D2 distance. Now last one is what? The D3, distance traveled by cream car, that is V into T. It is the distance traveled by cream car moving at a design speed V meter per second during the overtaking operation of the blue car, that is during overtaking time t seconds. That is very important, and here most care you have to take D3. While calculating D3, you should take the speed of overtaken vehicle speed, that is the fast moving vehicle speed, into the overtaking time operation. Then concluding remarks, how we can write, thus OSD equal to D1 plus D2 plus D3 for a two-way movement traffic. If it is only one-way movement traffic, then it will be what? D1 plus D2. Then what I can say, how about overtaking zones now? It is desirably to construct a highway in such a way that the length of road visible at every point is sufficient for overtaking. But this is seldomly practicable and there may be stretches where safe overtaking distance cannot be provided, but the overtaking opportunity for vehicles moving at design speed should be given at frequent intervals. These zones, which are meant for overtaking, are called as overtaking zones. The minimum length of overtaking zone should be 3 times the safe overtaking distance, that is 3 into d1 plus d2 for one-way traffic roads and 3 d1 plus d2 plus d3 for two-way traffic road. Desirable length of overtaking zones is kept 5 times the overtaking side distance, that is 5d plus d2 for one-way roads and 5d1 plus d2 plus d3 for two-way roads. This is, you can see very clearly in the figure. This is how the pictorial representation of the OSD. You can see S1, S2 are the signpost where the overtaking operation will be starting. S1 is the overtaking zone will be beginning, and S2 will be the overtaking zone will be ending for one direction. Similarly, it will be in opposite direction. You can see the OSD distance, which is the overtaking side distance. What will be the overtaking priority for the minimum and desirable length of the OSD, that is 3 to 5 times. Thank you, students.